Hello friends, welcome to part 2 of Altium PCB design video lesson. Now in this video lesson we have to route this PCB in order to generate the Gerber files so that we can able to send it to the board house for final production. Thanks to Altium software for sponsoring this video. You can download Altium free trial with the link given in a video description. Also you can simply sign up using the link altium.com/yt/binary updates and get the discount on your license purchase. If you remember, in a part 1 we have drawn a schematic and then we also have generated the board file. I can show you the 3D view. So when I press 3 on a keyboard it shows me a 3D view. When I press 2 on a keyboard it shows me 2D. Now before we route the PCB we have to do some settings here in a board file in our projects, and to do that we have to design, and then we have to go to layer stack manager. So in a layer stack manager we have to define the thickness of the PCB board that we want to get manufactured. So the dielectric one, which is FR4, which is a type of material that we will be using in order to generate this PCB board file, printed circuit board. So double click on this number, and then usually most of the board manufacturer will provide you 1.6 millimeter thickness. Control S to save the changes. So pretty common. I mean, most of the board houses support this configuration. Then come back to our board file. If it's not there, then you can just expand your source document and then you can see your board file. Right click and save. Then we have to do few more changes, and for that we have to set some parameters here. And to set the parameters, that's basically called a rules. So go to designs and set the rules. So click on rules, and then we have to set the clearance first. So under the clearance, if you expand, you have this minimum clearance which we want to give 1.3. Hit enter, and then we have to set the width. So the routing width, look at this routing. If you expand, under that you have a width, and here we have a preferred width to be set as a 0.5 millimeter. Then we have to set the minimum width, which is 0.3 millimeter. Then we have to set the maximum width, which is 1 millimeter. These are the specification. You have to check with your board houses, but this is pretty common. I mean, most of the board houses support this configurations, so the setting will work pretty well. So that's it. I mean, then we have to go to routing via style, because we will be using vias. And for vias, vias are basically a hole which connects the top layer with the bottom layer. This is a 2-layer PCB that we want to design and produce. So we have to go to routing vias, and in a routing vias we have to set the minimum diameter of vias will be, this is basically 0.6 millimeter. Hit tab button, 0.6. These are pretty common. I mean, this will be supported by most of the board houses. And then hole size 0.3, 0.3 and 0.3, and that's it. I mean, that's all we have to set. And then furthermore, if you want, you can also look at the silk to solder mask. So if you scroll down under manufacturing, when you generate the Gerber files, it's good to set a little bit earlier. So you have to look out the silk to solder mask. Under that, if you expand, if you see silk to solder mask clearance, and this usually I mean, it's good if you just put 0.1 millimeter. So that's good enough. And then you can just say apply and then say OK. So all the settings that we have done will be saved here. And then if you want, sometimes you see on the right side of the pan, this pan shows up here, and to hide that pan, so you go to setting, PCB editors, and then go to PCB editor, and in general you have to uncheck this enable auto pan. Otherwise you have this sticky pan here. These are the few settings you have to do before we start routing our PCB, and make sure all the settings been saved. Before we start routing this PCB track here, I want to show you something which I forgot. So go to design and go to design rules here, and in this somewhere we have a routing vias, no, something that I forgot, this one especially, unrouted net. So unrouted net, check for incomplete connection. So if there is any incomplete connections is there, when we compile the board file, it will show us an error. So it's good to avoid the possible errors while we are routing the tracks on the PCB board. So just check this box and say apply and say OK. And now we can start routing this PCB, and make sure the board layer is a top layer is selected. This PCB is basically a two-layer PCB. This is the bottom layer and top layer, so make sure you have a top layer selected, and then you can go to route and you can select interactive routing. This is one way, and you can see my mouse cursor. If I can zoom, hold control and press zoom, and then you can connect the components, this nets, RAS nets, what they call. So you can connect this legs of this LEDs, ground legs, cathodes, right? Or the other way you can do is here on a top, this what we say panel, you still have this option where you can select interactive routing. I will show you a little bit later, but right now you see my mouse cursor has this crosshair, and I can start connecting the tracks on a PCB. So I can just right click and hold and then drag this PCB to have a better view. So if you spend more time on this PCB layout, you will get comfortable with all the shortcuts and everything. Let me just show you by connecting few tracks, because I'm not using the auto routing tool. This routing can be done by automatically. In Altium they have this feature called auto route. I don't want to use it because I want to show you how you can manually route all the tracks on the PCB. So we are on a top layer of the PCB, and I can zoom a little bit for you to show. And look at this, when I take the mouse cursor here, I can just click and then I can hold it and then draw on the other LED's ground leg. So this is how these two pins are connected on the LED. These are like a cathode on the LEDs. And now that yellow nets is gone, that means we have successfully implemented the connections. So we routed the track of the both cathode of these two LEDs, so LED 9 and LED 10. Likewise, we can draw a track on a top layer and connect all the cathodes. Let me just show you how you can connect all the tracks. So this is how you're gonna repeat and do all the connections. So I usually prefer to do simple connections and then I touch the difficult connections. So I would also optimize the connection between this resistors and LEDs. So hold control and use zoom in and zoom out as much as possible because it's very handy. Let me just connect. Oh sorry, just press escape to if it's selected wrongly, then you can press escape. I can press escape to get out of this interactive routing, and if you want to unroute, you can select the track and then you can just say delete or backspace, and then to select interactive routing again to route the connection between this resistor and the LEDs. Here on the top, as I said, here again you can click this, and now the interactive routing will be selected. So I can just draw the connections. For all the LEDs with the resistor. You can do connection as per your personal preferences. Okay, so most of the yellow nets are gone there. That means the connections is done. Let me just optimize few more easier connections. So this resistor will connect to the pin number 1 on the CD4017 chip, and then we have to optimize few more connections. So this is the easiest connection I would like to draw here. So this is usually takes some time for you to get comfortable, but as you do more and more practice, you will get comfortable. That's how you connect the tracks. Now you can also do the connections of this one, and some of connections, some routings are easy, some are difficult. So the easiest one I prefer to do because it gives a better visibility when we get into solving the complex problem while routing the difficult tracks on the PCB. Then we have this one, and I would rather optimize this leg. You can always edit this as per your personal preference, as I said before. Sometimes when it looks ugly, you can just select, you have to first get out of this interactive routing selection, and you always use escape button to get out of it, and then you can route this path, and you can always just play around it, and you will do this. Now to get the routing again, interactive routing, to select, you can either press Ctrl W to wire command, which we have before. You can see my mouse cursor has this crosshair, or press escape, and now otherwise you can just click this here and still you get the interactive routing. And third pin I would like to finish. As I said, some tracks are easy to route and some tracks are challenging. I have never done this many videos and shoot and then do, but it really, you change your mind sometimes to optimize them properly. I'm just routing this legs quickly as possible, but I always come back and change the path which will be better suited for final production. These are just step-by-step optimization that I'm trying to do, and that's basically, this is my personal way how I make the connections. You don't have to do the same way as I do, how it make a sense for you, and then it's just a personal preference. So you can take your time and you can optimize all this PCB and draw all the tracks. So let me just do some more tracks to draw. Okay, looks cool. Now let me show you how we can place vias here. Look at this pin, right? This pin of the CD4017 chip, and this is connecting through this net to this resistor, right? So it's so complex, we cannot just draw, because if we draw on the top layer, so it will basically short. So we have to use the top as well as the bottom layer to draw the connections, and for that I think the best way is we can use a vias. Vias are something that allow us to connect the top layer and the bottom layer, so we can use both layer. So what I'm gonna do is I would just draw a little bit of the track here. Just right click, and then here on the, I think it's a R4 resistor. Let me check. 1, 2, 3 and 4. Yeah, this is the R4, and then I'm going to draw a small track here. Now you see they both are connected. Now I just press escape to get out of the routing, and then I select vias here. Look at this on the top, the sticky panel. So we can click here, and now I have the vias, so I can place my vias here, and then I place the vias here. And when I place the vias, you see it shows me some kind of dot. It says that means it's connecting, so it's not really good to place that. So what I personally prefer to do is I just click escape, I move this track a little bit up to create a little bit of space. So this is the advantage of doing manual routing. You can have your personal preferences how you place your components. So now I select the vias, and now I place, and now they don't connect to the top, on the top of the track, right? So now there's no problem. If you want, you can move this vias a little bit, and but it may be not needed, or it may be needed. It just depends, right? You can just move it like this. So this is what I would keep the connections. And now you have to select the bottom layer, because from the bottom of the PCB printed circuit board we have to connect these two vias, right? And I would again select the interactive routing here. either I click here or I can press Ctrl W, and then I will now draw the track, and it's not really difficult, and the yellow net is gone now. It basically shows the connections are done. Press escape to deselect. Now come back again on a top layer, select the top layer, and now we have to finish the other connections. So let's make the easiest connection, this one with this track. Okay, so Control W on a keyboard, and let me just draw these connections. I want to keep some space a little bit later to optimize it, because I know the routing that we are doing is not the best, but I would always come back and change it as per my personal preferences, right? As I said, nothing is perfect on a first shot. You really have to spend some time in order to optimize the circuits and tracks to fit better. And now let me see which track I could optimize. So look at this one. This point should connect to this resistor, and I can use vias again for this. So I would just put one track here on a top layer, and then I make one more track I can draw here. Click and right click, and then press escape, and then I would place the vias. So select the vias, place vias, and put one via here, and put one via here, and press escape to get out of vias. Select the bottom layer to draw the bottom track, and Control W, and now you can just draw a small track here for the connections. If this doesn't looks better, as I said, you can always come back and make it much better. I mean, it should also have the logical connections. It's not always just the connections for the sake of connections. And now I see there's one more track, especially this one. This one is connecting to this one. This is really long. So Control W and oh sorry, escape, and I have to select the top layer. Control W, and then I just have to put the vias here first, and then I have to draw one more track here on the top, and now I can just place a vias here. So one vias here, one vias here. Press escape, select the bottom layer, Control W to route the track. So let me just draw the track. The easiest one would look like this, hopefully. This yellow net is gone, that means they are connected now. Press escape, and look what else you can optimize here. And looks cool here on a decade counter chip. Most of the things are done. I think this one is left, so I would just select top layer here, back again, and Control W, and I have to draw this the best way I can do is like this. So it's gone. Now I can just connect this track, and you can see it shows me the possible connections. It's gone now. What else remains? And this connections, you can move it like this. This would be probably the easiest one. Yeah. And what else? Okay, you see here there's a yellow net. We can also optimize. This is the easiest one, so I don't mind this to finish. Now it's gone. So this part looks cool. I can just connect this 2 resistors ground pin, and now that's also gone, so looks pretty neat and clean. Now we just have a few connections left, and this part looks a little bit challenging, right? We have to spend some time to figure out the connections here. And this track, I think it's possible that if I can draw like this, maybe I can just draw maybe. So that's it. And what else? This ground connection could be done it like this. So maybe I will just draw the one leg. Not sure, but this is possible, right? It's gone. So looks not bad. I would of course would like to spend a lot of time to optimize the tracks to look more professional and better, but right now I just want to finish the connection, or I can say escape, and I would like to take this track here. Maybe I would just put one up there, and maybe I would connect from here. Maybe it's not very good connection, or maybe press escape and just move a little bit there, control W, and just have a not very good, but I would optimize this bit later. Not sure if this escape, and I would just remove this if this track make a sense. Okay, just to finish this quickly, I would just put some vias here and then select the bottom layer, and I want to connect. So press escape, and I think Control S to save the changes. Now what else? I would of course later work and optimize this. I have to figure out how I would finish them. So one way, I could just select the top layer again because I was on a bottom layer, Control W, and I would put here connections, and here I have one track. Okay, I can just draw this, extend this one. Not sure, I have to take a little bit like this, and then maybe I have, oh no, maybe you can make small. Press escape, select, put the vias and escape. If this vias is too close, then it will later show us the problem, and this happens usually, so you have to be very careful when you put the vias. So select the bottom layer, Control W, and just draw the connections from the bottom side of the PCB, and now that connections are done. Now here I have few connections which I have to optimize. Press escape to come out of the routing mode, and now I have this connections looks pretty long and not so good optimized, but I would just press Control W and then just draw here this both pins, because I know that it will requires the vias. I have to take these connections from the bottom, and what else, where this connecting, this leg is connecting to this resistor, and also this connection is also left, right? So I have to figure out how can I do these connections. Okay, better I would first optimize this connection, so Control W, and maybe I would just Okay, escape. And how am I going to do this? By having this connections. Okay, this maybe I don't need. And then control W, and maybe here I have enough space. Then I put vias here and one vias here. Escape, select the bottom layer, control W, and I connect. Looks, the connection is made successfully. Now the second pin, this one, is connecting to this one, right, which looks a little bit tricky. The second pin, which is where it's gonna go and come for the top routing. So control W, sorry, press escape, select the top layer, control W, and this track, I believe it should be the good choice in a long term. Okay, press escape, that's gone. What else left is this third pin, right, from the lower right side, and this connections would go to this one. Look like if I can make escape and then I can draw this. Let me see if I can take this, right click, and then put the vias, escape, and let me put the vias for this and for this. Escape, select the bottom layer and draw the track from the bottom, and now it's gone. Now the difficult connections, there's one more left, which is this one, right, which is a little bit challenging. For this track I believe I have to optimize now. So select the top layer, control W, and I use the space between two resistors, and now I would put one vias here and one via, I have to put it here. Escape. You can move a little bit if in case you want. Sometimes they are too close, and now you can draw the track on the bottom layer. So select the bottom layer, control W, and you of course can able to draw this track. I think it's done. Press escape, select the top layer. Now I have these connections. Looks the complex one. I need vias again for this layer, this pin. So I take this and right click here, and then I have this two connections to be made. So escape, I will place vias here. Just want to make sure it's not connecting to anything, otherwise it would create me a trouble when I compile the PCB file. So now I place the vias and select the bottom layer, control W, and now I can just let me see how best. I think this connection is done. Press escape. Now there's one connection left which looks pretty complex here. Not sure. Okay, that's the track 1 with the VCC, but I think this is pretty straightforward. I think if I go to top layer, Control W, this connection will be straightforward, I think. Yeah, it's done. Now one connection left, which will come to, it shows to this vias, right? So this lake, so this resistor has to connect to this lake. And let me try and see if I can draw this track here. And now it's done. So I know that this connections are not perfect. I would spend some more time because this is all live I was doing. Going forward, we will able to compile this board file, and before compiling this PCB board file to check for potential error, I want to spend some time to optimize this PCB, and this file will be given in the downloads in the GitHub repository. You can download that and you can study the tracks that I have drawn, and then you can draw the tracks accordingly. So now we have finished a complete routing of a PCB here with all the components. So it's very important for us to check whether there is any possible errors or some unconnected route paths or something like that. So any error or potential warning before we do any further optimization or generate a Gerber files or something like that, we have to make sure there's any error or something of that sort. And to check for potential error, we have to run something called DRC. It's called design rule check. For that we have to go to tools, and in the tools we have this option called design rule check. So when we click on design rule check, you see it gives us this pop-up box where there is in the lower left corner run design rule check. So when I click on run design rule check, then you see it shows us this design rule verification report, and if I can scroll down, you can see the warnings are 0 and the rule violations are 0, and everything looks pretty cool. So the routing that we did, I know it's not perfect routing, but it doesn't have any violation or error or something like that. If you want to check something more, then in the lower right corner there's a panel. When you click on panel, then there's a messages. So when you click on messages, you see there's no message. If there is any error or warning or something, then if any pins are short or something like that, if anything is unconnected or unconnected routes or pins or something like that, you will see the messages shows up as an error or potential warnings. But since I have done it very carefully, and I have not optimized properly this routing tracks, I would further optimize in my own free time, because online it's really difficult for me. So but even if you produce the Gerber files for this one, it would work absolutely fine. So that's basically how we check there's no error or no warnings or something like that. So this PCB is absolutely fine, the routing paths are perfect. Now we can further optimize this printed circuit board. Now I think it would be a good practice for us to add a Polygon pour for this PCB, to add the Polygon pour before we generate a Gerber files and do other housekeeping stuff on the PCB. Adding the ground pour, Polygon pour is very important, and for that we have to select the bottom layer. So once we select the bottom layer, then we have to go to place, and then there is something called Polygon pour. So select the Polygon pour, and you see my mouse cursor, there's this cross here, so we can select, click here on a corner, lower left corner, and then you can just draw the Polygon pour on every corner of the PCB. So let me add. So here it is, and then it finish it here where we started. And now it's still selected, but we have to go to properties here, and net for the polygon pour we have to select as a ground, and the layer, it's a bottom layer, so we are fine. Now right click to deselect, and now you see the PCB board file shows up here for us, right? So after adding polygon pour, we can really be able to generate the Gerber files, but I think it needs to be done more uh, optimized way. So what we're gonna do is, once the polygon pour is added, again right click and save the file. Okay, and then I'm going to select individual component here, like let's say this one, and I would make it visible, this R13 as a name of the component. I select now this, you can deselect the component pour. Basically right now when I select the top layer, it's gone now, the polygon pour. So now I select this component here, and U1 is the name of this component, and height is 1 millimeter. I want to make it more meaningful, so more visible, so 1 millimeter smaller looks better. And now you can see the name shows up. So something for this resistors is very important, because every resistor has connected to the LED here. So I select the resistor, and let me just check if I can. Okay, just select the resistor, and I think all those resistor make it visible. And let me check. Okay, so here goes the resistor. You can use the space bar and place it, and you can just make it 1 millimeter. I think this size looks better, so I select all those resistors. Let me just select, hold control and select all the resistors, go to properties, and I just make it visible. And then I select all those comments. That's basically a name of all of them. So go to properties, and I make it 1 millimeter, so they looks a little bit smaller now. And let me just take every of the components, so R2, then we can have this R3, so the PCB will look much better. R4, R5, R6. It's not important to do this, but I'm just doing it because I want this to look a little bit better when we generate the Gerber files. R8, and it also helps when you do soldering of the components, you know which component is what. So R10. So we have now all those resistor, which is a 1 kilo ohm resistor. If you want, you can make it visible for this and this resistor as well. Go to properties, make them visible, and once they are there, you can select both of this comments and make it 1 millimeter, so looks smaller. Smaller is better. Oh, Control C, and make sure you only select the text, not the routing tracks, otherwise you will disturb the connections. Just move and place them properly. And then we have this two capacitors. Go to properties, designator 1 millimeters, Not sure whether they are selected, so make sure both are selected and then make it the height of the font, and then this one is C1, which is 1 microfarad, and this one C2. C1 and C2 both are 1 microfarad basically. Both capacitors are 1 microfarad capacitor, and basically these are R11 and R12. So R11 is 2.2 kilo ohm, so this R11 is 2.2 kilo ohm, and R12 is 10 kilo ohm resistor. You can either put it like this, so you can check on a schematic like what is the value of particular resistor or something like that. But now our PCB is ready. If you want to give some name, you can also put some text on the board. Rather avoid this for now. I just want to make it very clean, neat and clean and simple, to the point and focused. So this PCB is basically ready to generate the output files, that means Gerber files. If you want, you can able to see the 3D view. So now look at this, how the 3D view looks like. So you can just zoom in and zoom out and see. Now it looks a little bit better. So 2D view and 3D view. So in the next video we will generate a Gerber files that will be required to the board house to manufacture this PCB, and then in the next video lesson we will not only generate the Gerber files, but we will use the Gerber views to test whether any potential issue or something like that, to measure the distance between the tracks and the components, and then we will send it to the board house, and then we will get it manufactured, this PCB, so that we can test the actual PCB and see if it works. I hope you have found this video educational and entertaining. We'll see us into the next video lesson. Bye bye for now.